At the end of the day, it's high strength, it's highly corrosion resistant, it's very cost effective really in terms of bangs for bucks, the properties you get.
Welcome to another technical corner. Now today we're doing something fascinating. We're talking about a bit of material science. We don't often cover this. And to start with, Rodney, you've brought something very special here today. This has been invented by Langley Alloys.
I'm loving the enthusiasm, Rowan. It is. So this grade, Ferralium 255, was developed and marketed and promoted by Langley Alloys. There was a patent put in place in 1968, so it's been around and in the market in use for more than 50 years. And it was the first real commercial Super Duplex stainless steel on the market, so it's quite a proud thing for our company to be able to talk about.
Yeah, absolutely. First real commercial Super Duplex is amazing. Langley Alloys has been going for a bit longer than the 60s though, hasn't it?
Yeah, the company can trace its history back to 38, effectively a coming together of two companies making really quite special alloys for naval and aerospace applications, and then through the 40s, 50s, 60s they carried on with that development work, and that led to this Super Duplex stainless.
Brilliant, doing kind of R&D in really fascinating.
Oh, it would have been back in the day, yeah. All sorts of laboratories and testing and initial manufacture, and then market development stuff. So really cool stuff.
Yeah, absolutely. Before we talk about the material, let's now go to where Langley Alloys are today.
Yep.
And how much you stock, what kind of materials you stock, what you offer the market.
We've got history in grades such as this, and over the years we've broadened that out. So we've got a pretty clear focus on some nickel alloys, duplex and super duplex stainless, some high performance stainless, and a couple of copper nickel alloys. But basically high strength, high performance alloys for applications that are typically wet and corrosive. And that's the thing that they all generally have in common. They perform really well in that sort of aggressive environment.
Brilliant. We'll be talking a little bit more about where this component's actually going to go a little bit later. But first of all, what material is it, and what's it made of? So
we've already said it's called Ferralium 255. It's a super duplex stainless steel, which is a bit of a mouthful, but that effectively means it's almost like a composite. It's a mixture of an austenitic stainless steel and a ferritic stainless steel, which, unless you're a metallurgist like me, is probably whatever. Not
probably a bit
so
of gobbledygook to some people.
However, what that means is it performs, or it provides a really good mix of properties of those two different types of metals. Now, for a metal to be considered stainless, it needs 11% chrome. This has got 25% chrome, and what that means is it will have much better corrosion resistance. But to make it more cost effective, it also pioneered the use of nitrogen in there as well, which is a much lower cost material. So you've got high chromium, you've got nitrogen for really good corrosion resistance. You've got this mixture of austenite and ferrite, which gives it good strength, resistance to cracking. And it's relatively cost effective as well. So you get a lot of bangs for your bucks. It's also got copper in there as well, and copper's known to perform well in sulfuric acid. So there's 2 or 3 alloys on the market that include copper, and this is one of them, and that informs its use in a few industrial processes where sulfuric acid is widely used.
Wow, so there's a lot of different properties there that are quite, I guess, attractive for a design engineer.
Yep.
Let's talk about the kind of result of that on what it's like to machine.
Okay, it depends where you're coming from. So if you're used to dealing with, let's say, a commodity stainless steel, a 316, then this will feel difficult. If you're coming from a carbon steel background, it will feel even more difficult. So why is that?
We're not trying to scare anyone off though, it's still machinable.
No. So it is, and obviously there's lots of it have been machined for many years into much more intricate components than this, but it's high strength. So already you're needing to use tooling and a machine tool that's pretty robust and strong. That's one. As a stainless steel, it will have a lower thermal conductivity, so there's a potential for building up heat at the tooling tip.
You need to use coolant, make sure you get the heat out of the cut.
Yeah, and there'll be people that will be far more expert on that process that will get very excited about speeds and feeds and geometries and the rest. So that's part of it. So it will work harden as well. So perhaps counterintuitively, you want to go relatively hard
deeper,
and fast.
Get under the material, cut it out.
Don't let it harden.
Yeah.
But the one thing that gives it really good properties also creates its own challenges, and that's this mixture of austenite and ferrite, which means that duplex and super duplex grades can be prone to a phenomena that machinists might call movement or relaxation. So in between machining processes, you get that relaxation of internal stresses within the product, and it may just shift a millimetre or two. So the machinists that we would speak to as a business will have their own strategies in a way of how to accommodate
secret way of doing
it.
How
to accommodate that, through custom and practice.
And if we talk about the component here now, obviously those horrible some might say horrible machinable characteristics, some might say usable machinable characteristics. There's a reason these materials exist. It's not because they're great to machine, but it's because they're really useful in certain conditions. What's it used for?
This, pretty chunky lump is a canister, a protective canister inside which some very expensive, very sensitive electronic equipment will go. The canister is there to provide protection, so it needs the strength, it needs to be able to withstand the knocks, and it's going to be dragged around the seabed, so it has to be highly corrosion resistant as well. Absolutely. But it's a large chunk of metal, so you also want it to be cost effective. So it's just striking the balance between corrosion, strength, and price. I'm just protecting the really sophisticated stuff that goes inside.
It's fascinating seeing the applications of these materials, and I know that, like many materials, it's not without its challenges, but because of the applications it can be used in, it must be very useful material.
At the end of the day, it's high strength, it's highly corrosion resistant, it's very cost effective really in terms of bangs for bucks, the properties you get. We've been making and distributing this for 50 years plus, and there's thousands of tons out there in the marketplace still performing incredibly well in really aggressive environments. So I think that little bit of effort is probably worth it, yeah?
Yeah, absolutely. So if you want to get in touch with Langley Alloys, Ferralium is a material you can only get from them.